We're going to take a look at a second example of using our discrete distributions to be able to find some probabilities and then to interpret a scenario. So let's say for some reason we know that a basketball player has to make three free throws. Tough to say. The probability that she makes none of these free throws is 6%, one free throw 13%, two free throws 64%, and then all three of them are 17%. And we're going to do exactly the same thing that we did in the previous problem. We're going to find the probability distribution, construct a distribution, compute the expected value, and then interpret it, find the standard deviation, and then find the number of free throws that are considered outliers. Right, so first things first, let's construct the frequency or the probability distribution. So we have outcomes. And the outcomes are you either make 0 free throws, and we can go right down the line from there. 1 free throw, 2 free throws, or 3 free throws. Now, a very common error that students will make is that they look at the values that are given. Okay, so there's that 13%, 6%, and etc. And they think that those are the values. Right? So remember the next column we have their values, which are x. And so what they'll do is they'll say, well, this is 0.06, and this is 0.13, etc. And that's not correct. In fact, what's given is the probabilities this time. All right, so in this case, we actually have P of x, which is going to be the 0.06 for 6%, and then 0.13, and then 0.64, and then 0.17. Right, so what is x going to be? Well, x is the number of free throws that the player makes. So 0 free throws, 1 free throw, 2 free throws, 3 free throws. Right? So that's for letter A, our probability distribution. A little bit different than the previous problem, because in the previous problem, we weren't given probabilities, we were given the values for that. Okay, so in this case, we were given the values, they just were a little bit less explicit. Right. For letter B, we need to find our mu. And remember our formula, mu is equal to the sum of x times P of x. And just put a bracket in there. And remember what we do, we just multiply. Right? So right here, this is going to be our x times P of x column. And so we have 0 times 0.06, which is 0. We have 1 times 0.13, which is 0.13. We have 2 times 0.64, which is going to be 1.28. And then finally, we have 3 times 0.17, which is going to be 0.51. And of course, if you don't trust me, certainly go through in your calculator and make sure that you compute those, okay? Just to check. And then finally, what we do is we add those up, and that's going to give us the sum. Okay, so I'm just going to do that in the calculator real quick. So we have 0.13 plus 1.28 plus 0.51, and that gives us 1.92. And that is our expected value. Okay, so the mean mu is going to be 1.92. And so what does that mean, no pun intended, but what does that, in the context of this problem, how do we interpret that? Right? So we also have to interpret the value. And this is basically, if the player were to make 3 free throws in a large number of games, we would expect the player makes about 1.92 of those free throws out of every 3. Okay, so to interpret this, this means that the player is expected to successfully make 1.92, okay, or since we can't make 1.92 baskets, we can say about 2, right? That's probably the closest number that we have. Free throws out of every 3 attempts. So hopefully that makes sense, all right? If you ever get sort of this discrete value, all right, that doesn't really make much sense, or I'm sorry, continuous value that doesn't make much sense in a discrete situation, then what you do is you just go through and round it, all right, make it pretty close. Now, next thing we're going to do is we are going to find the standard deviation. And remember, for our formula for sigma, that's going to be the square root of the sum of x squared times p of x minus mu squared. And remember, mu is 1.92 from the previous problem. All right. So what we need to do is we need to find that x squared p of x. All right. And you might remember that x was 0, 1, 2, and 3 from the previous problem. And we had probabilities, you might remember, of 0.06, 0.13, I think it was 0.64. Yep, and then 0.17. Okay, 06, 13, 64, and then 0.17, I think. Yep, 0.17. Now we need x squared. And by the way, it doesn't matter what order these columns are in. I think in the previous example, maybe I did x squared first. It doesn't matter. Right? So x squared, we're going to square each of the values that are given for x. So that's 0, 1, 4, and 9. And the last column is going to be x squared times p of x. So we're just going to multiply. So it's going to be 0.06 times 0, 0.13 times 1, 0.64 times 4, and then 0.17 times 9. First one's 0, second one's 0.13. I think this is 2.56. And then for our last one, we get 1.53, I believe. Now I'm going to check these just to make sure, because we have to add them up anyway. So we have 0.64 times 4, and then we have 0.17 times 9. So we get 2.56, which I got, and then 1.53. And then all we're going to do is we're just going to add up these three numbers. So we're going to have our 0.13 plus 2.56 plus 1.53, and that yields 4.22. Now that is not the deviation, okay? So just hold on. This is our 4.22, which is our sum of x squared p of x. But again, that's not the standard deviation, okay? The standard deviation can be found by substituting that back into this formula. Okay, so sigma is going to be equal to the square root of our 4.22 that we just got minus 1.92 squared. Right? We don't need the parenthesis like we did in the first example, just because the value is non-negative for mu. Sigma, we're going to put that in our calculator. So we get second square root 4.22 minus 1.92 squared, and that yields 0.7073. That's our deviation. Okay, so less than one basket is going to be the standard deviation for each time. And then finally, what are the outliers for this? And then, of course, do the outliers make any sense? So remember that the outliers are going to be when x is greater than mu plus 3 sigma, and when x is less than mu minus 3 sigma. All right, so that's going to be 1.92 plus 3 times 0.730, and 1.92 minus 3 times 0.730. All right, so let's just throw that into the calculator. So 1.92 plus 3 times 0.730. And then remember that trick, you can hit second enter. That brings up the last command that you input. And instead of a plus, we're going to change that to a minus. And that's going to yield negative 0.27. All right, so 411 and 0.27. So 4.11 and negative 0.27. So it has to be greater than 4.11 or less than 0.27. And of course, in this context of this problem, that makes no sense because the most number that we can throw for the free throws is 0, and you can't make 0 free throws. All right, so in other words, the negative doesn't make any sense. So again, this is, you could say, nonsensical or nonsensible in this problem. All right, but again, we do know how to compute them, and it's just theoretical probability. So, I mean, we certainly expect that it's very difficult to make 3 free throws in one sitting, and we also would suspect that if the person's been playing a long time and they have a 64% chance of making 2, it'd be very difficult for that person to make none of them, all right, if they were trying. So hopefully this makes sense for our first 2 examples. Now, in the last example we're going to look at, we're going to look and see what happens if the probabilities are not given or if they're not easy to find. Okay, so we might have to go back, we might have to use some of our previous definitions to help us build our discrete distributions, and that's what's going to be in our last example.